Alright, today we're going to start having a look at some fractions. So, fractions are just numbers, but they're not numbers used for counting how many objects there are or anything like that. Instead, they're used to describe quantities you get when you cut up one whole or more into little bits. Okay, so this rectangle is going to represent the number 1, and we're going to look at this fraction here. Right. Now the bottom number, that little 3 there, that tells you how many bits to cut this rectangle into. Whereas the top number tells you how many of these bits you want to actually take. So what I've shaded there, that's going to be the number 1 out of 3, or 1 over 3. If I change it to a 2, that would mean 2 out of 3, like that. Okay. So once again, that bottom number, which we'll call the denominator, that tells you how many bits to cut the whole thing into. While the top number, the numerator, tells you how many bits to actually take. Right? And the way we talk about these is a few different ways of writing and talking about them. I think I've already used a few of those. It's 2 over 3, or we sometimes say 2 out of 3. But most importantly, the one to notice there is that this means the same as 2 divided by 3. Right? Because both fractions and division carry the same meaning of cutting something up into bits. So over 3 or divided by 3, they mean the same thing. Okay? Alright, have a look at these two fractions here. 1/2 and 1/5, 1 over 5. Alright, a common mistake we see people make is because 5 is bigger than 2, they think that 1/5 is bigger than 1/2, right? But actually it's quite the opposite. Alright, because what 1/2 means is to cut up this guy into 2 equal bits and see how much each of those bits is. So that's how big 1/2 is. Each of those is worth 1/2. Whereas for 1/5, you're cutting this thing up into 5 equal bits, like so. And so what you notice straight away is that each of those parts is actually a lot smaller. Because you've cut the block into 5 bits, more parts, each of those parts will be worth less. And so actually increasing that bottom number, increasing the denominator, generally gives you a smaller number. Okay? Alright, let's look at 2/3 again. But I'm going to cut this thing up a lot more. So let's have a look at this. What happens if we do this? Right? We've now cut up the whole block into 6 equal parts if you count that. So that means the bottom number could well be 6. And if you look at the blue part, well, there's 4 of those. So we've taken 4 out of the 6. But the important thing is we have not changed the amount of the blue part that we've taken. The size of the blue bit, we haven't actually changed that. Right? We've cut it up into more parts and we've taken more of them, but we haven't changed what the value of the blue part actually is. And so these two fractions are actually equal. Right? Likewise, if we cut this thing up again into even more bits, this time we're cutting it up into 9 parts, right? And if you look at the blue section again, you'll see you've taken 6 of them. All right? And again, we haven't changed the size of the blue shaded section. So actually, 2/3, 4 over 6, and 6 over 9 are all the same fraction. They're equivalent, we say. Right? And what's the pattern here? What's happened, say from 2/3 to 4 over 6, what happened was both top and bottom got multiplied by 2. And I guess the meaning of that, multiplying the 3 by 2, means that each piece got twice as small because we cut it up into more bits, so each bit became twice as small, but then the top one says we took twice as many of them. And so of course we've taken the same amount. And likewise, if we do 2/3 to 6 over 9, what's happened there? Well, we've just multiplied top and bottom by 3. So what does that mean? Well, multiplying the bottom number by 3 made each piece 3 times as small. Whereas multiplying the top by 3 made us take 3 times as many. But again, those two things cancel out, and really we've taken the same amount. So in general, and note this, multiplying or dividing the top and bottom by the same thing won't change the value of the fraction. Because if when you're changing the bottom number, like multiplying the bottom number by something, it just makes each piece smaller. But then if you multiply the top by the same thing, you're taking that many times more, and so you've actually cancelled those two things out exactly. And so it's the same fraction in the end anyway. Okay. Now, one final note with this is that if you instead try to add top and bottom, and we see this a lot, people add top and bottom, same number to top and bottom, say to three quarters, that means something completely different. Okay, so if you just look at those two, you'll see 2/3, 3/4, they mean something very different, right? And so you cannot add and subtract the same thing from top and bottom. It doesn't work that way. Okay, you can only multiply and divide top and bottom by the same thing without changing the value of the fraction. Okay. All right, so this leads us to simplifying fractions. Simplifying means we're looking for the highest number to divide both top and bottom by. All right, now notice that it's only one number to divide both top and bottom by, because we have to divide them by the same thing, otherwise we'd be changing the value of the fraction. Okay, and the idea, the goal of this is to make those numbers as small as possible, but it doesn't change the value of the fraction because we're dividing by the same thing. Okay, so say we take the fraction like 18 out of 30. Okay, and you'd be thinking, got to know your times tables for this, you've got to be thinking, well, what goes into both 18 and 30? What can I divide them both by? Right, now it could be thinking 2, or you could be thinking 3, but you want to try and find the biggest one. Right, it doesn't matter if you don't find the biggest one straight away, but then you really just got to make sure that you simplify again if you need to. Okay, but the biggest thing I think you can divide both 18 and 30 by is 6. Okay, and notice again, it's the same one top and bottom. If you divide 18 by 6, you get 3. Divide 30 by 6, you get 5. And so 18 over 30 is the same as 3 over 5, but 3 over 5 is the simplified version, okay, because it uses the smallest possible numbers to express the same fraction. Okay, so that's our first look at fractions. Thanks for watching. I'll see you guys next time. Bye.